Now we need to count back in hundreds. So first we have 100,640, 100,540 and 100,440. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting back in hundreds is just like counting back in ones, but with our tens and ones digits staying the same. So we know that if we're counting back in ones, the number before 1000 is 999. And that means if we're counting back in hundreds, the number before 100,040 is 99,940. Now we have 244,444, 244,344, 244,244. If we show the next numbers in this sequence, again we can see that what we're really doing is counting back in ones, but then leaving the tens and ones digits the same. So let's show place value counters to represent our counting. For this first question, we started with 100,640, so we can show 100,000 counter, no 10,000 counters, no 1,000 counters, 600s, 4 tens and no ones. We were counting back in hundreds, so we can take away one of our 100 counters each time. But now, because we're counting back in hundreds, we need to exchange our 100,000 counter for 10,000 counters. Then we need to exchange one of our 10,000 counters for 10,000 counters. And now we can exchange one of our 1,000 counters for 10 hundreds. So now we can keep on counting back until we get to 99,740. So that's 9 10,000s, 9,000s, 700s and 4 tens. Then we started with 244,444. So that's 200,000s, 4 10,000s, 4,000s, 400s, 4 tens and 4 ones. We were counting back in hundreds, so we can take away a 100 counter each time. But now, to get more 100 counters, we need to exchange one of our thousands for 10 hundreds. So now we can keep on counting back until we get to 243,544. So that's 200,000s, 4 10,000s, 3,000s because we had to exchange one of them, 500s, 4 tens and 4 ones. Now we need to subtract a multiple of 100. So if we highlight our hundreds digits, we have 8 minus 5. So our hundreds digit will change to a 3. All of our other digits will stay the same. So our answer is 49,382. Now we have 10,191 minus 500. But here, if we highlight our hundreds digits, 5 is more than 1. So what we need to do when this happens is highlight digits to the left as well. But in this number, to the left, we have a 0. So we need to go all the way over to our 10,000s digit, and then we have 101 minus 5. That's 96. So our answer is 9,691. Because 101 minus 5 is 96, and then our tens and ones digits stay the same because we're not subtracting any tens or ones. So here we have 284,529 minus 800. If we highlight our hundreds digits, 8 is larger than 5, so let's highlight the place value to the left as well. That means we have 45 minus 8. That's 37, So these digits here will be replaced with a 3 and a 7, and all of our other digits will stay the same. So our answer is 283,729. Now 100,394 minus 600. If we highlight our hundreds digits, 6 is more than 3, but we go to the left, we have a 0, and we go to the left again, we just have another 0. So we need to go all the way over to our hundred thousands digits and work out 1003 minus 6. That's 997. So our answer is 99,794, because 1003 minus 6 is 997, and then the 9 in our tens and 4 in our ones stays the same. So let's have a look back at this first question. We started with 49,882, which we've represented here with place value counters. So if we subtract 500, we're just taking away 1, 2, 3, 4, 5 of our hundred counters, and that means the only thing that's changed is that we now only have 3 hundreds. But then we had 10,191, which we've shown here, but we needed to subtract 500. Now we can subtract 100 counter, but then to get more hundred counters, we need to exchange. We can exchange our 10,000 counter for 10,000 counters, and then we can take one of those 1,000 counters and exchange it for 10 hundreds. So remember, we'd already subtracted one of our hundreds, so to subtract 5, we need to subtract 4 more hundreds, and that gives us 9,691. So that's why our thousands digit changed as well, because here we needed to exchange. Then we had 284,529, which we've shown here using place value counters. We needed to subtract 800. Now we can subtract 500 counters, then exchange, then subtract 6, 7, 8, so that leaves us with 3 in our thousands and 7 in our hundreds. So that's why our thousands and hundreds digits changed. We did 45 minus 8 to get 37, and that told us that we would have 3 thousands and 7 hundreds after we'd subtracted 8 hundreds. Then we had 100,394. We needed to subtract 600. We can subtract 1, 2, 3 hundreds, but then we need to exchange our 100,000 counter for 10 10,000s. Then we can take one of those 10,000s and exchange it for 10,000s, and then take one of those thousands and exchange it for 10 hundreds. So remember, we've already subtracted 300 counters, so we need to subtract 4, 5, 6, and that leaves us with 9 10,000s, 9,000s, and 700s. So that's why working out that 1003 minus 6 was 997 gave us our answer, because of course our tens and ones have stayed the same. Now we need to count back in thousands. First we have 103,555, then 102,555, 101,555. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting back in thousands is just like counting back in ones, but with our hundreds, tens, and ones digits staying the same, because we're taking away 1,000 each time. Now 355,222, 354,222, 353,222. If we show the next 7 numbers, again, we can see that we're counting back in thousands because our thousands digit is decreasing by 1 each time, and then our hundreds, tens, and ones digits are staying the same. Now let's show place value counters to represent what we've counted. So for this first question, we started with 103,555, which we've represented here using place value counters. We were taking away 1,000 each time, but then, now that we don't have any thousand counters, what we need to do is exchange. We can exchange our 100,000 for 10 10,000s. Then we can take one of those 10,000s and exchange it for 10,000s. So now we can continue counting back in thousands until we get to 94,555. Then we started with 355,222, which we've represented here. We were counting back in thousands, so that's taking away 1,000 counter each time. But now that we don't have any more thousand counters, what we need to do is exchange with our 10,000s. We can exchange one of our 10,000 place value counters for 10,000s, and then we can continue counting back in thousands until we get to 346,222. Now we need to subtract a multiple of 1,000, so a number that ends in 3 zeros. First, we have 28,284 minus 2,000. If we highlight our thousands digits, we have 8 thousands and we're subtracting 2 thousands. So in our answer, we will have 6 thousands and all of our other digits will stay the same. So our answer is 26,284. Now we have 231,932 minus 5,000. Again, we can highlight our thousands digits, but this time we're taking away more thousands than we have. We have 1,000, but we need to take 5,000s away. So what we need to do here is highlight the digit to the left as well. So now 31 minus 5 is 26, and that means that we can replace these digits with a 2 and a 6. All of our other digits stay the same, so our answer is 226,932, because 31 minus 5 is 26. Now 286,745 minus 8,000. If we highlight our thousands digits, 8 is larger than 6, so again we're going to need to highlight our 10,000s digit as well. So now we have 86 minus 8. That's 78, so we can replace these digits with a 7 and an 8. All of our other digits stay the same, so our answer is 278,745. And now 400,400 minus 4,000. If we highlight our thousands digits, 4 is larger than 0, and this time when we go to the left we have a 0. So that means we need to go to the left again and highlight our 100,000s digit as well. So now 400 minus 4 is 396. So our answer is 396,400 because our hundreds, tens and ones digits stay the same. So let's look back to this first question and use place value counters to show the subtraction. We started with 28,284, which is represented here. To subtract 2,000, we can just take away 2 of our 1,000 place value counters, and that leaves us with 6,000s. But then we started with 231,932, which we can see here. Now we needed to take 5,000s away, but we only had 1,000. So we can take away this 1,000 counter, but then to take away 4 more thousands, what we need to do is exchange one of our 10,000s for 10,000 counters. So then, because we've subtracted 1,000 already, we need to take away 2, 3, 4, 5, so that we've subtracted 5,000 counters altogether. And you can see that in our answer, we now have 2 10,000s and 6,000s. So here, our 10,000s digit had to change as well, because to subtract our thousands, we needed to exchange one of our 10,000 counters. Then we had 286,745, which we can see here. We needed to subtract 8,000. We can subtract 1, 2, 3, 4, 5, 6, then exchange, then subtract 7, 8. So we now have 7 10,000 counters because one of them we needed to use to exchange for 10 more thousands, and now we have 8 thousands. So that's why we could highlight not just our thousands digit, but our 10,000s digit as well, and 86 minus 8 is 78, which tells us that we will have 7 10,000s and 8,000s in our answer. And of course, all of our other place value counters have stayed the same. Finally, we had 400,400. We needed to subtract 4,000, but we don't have any 1,000 place value counters here. First, we can take one of our 100,000s, and that has the same value as 10 10,000s. But now we can take one of our 10,000 counters and exchange that for 10,000s. So now we can take 1, 2, 3, 4 of these 1,000 counters away, and that gives us an answer of 396,400, because we've now got only 3 100,000 counters, 9 10,000 counters, and 6,000 counters. Now we need to count back in steps of 10,000. First, we have 135,400, 125,400, then 115,400. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting back in steps of 10,000 is just like counting back in ones, because we're subtracting 1 10,000 each time. And that means our thousands, hundreds, tens, and ones digits will stay the same. So we know that if we're counting back in ones, the number before 10 is 9. And that means that if we're counting back in steps of 10,000, the number before 105,400 will be 95,400. Now we have 944,005, 934,005, then 924,005. If we show the numbers that follow, again, we can see that because we're subtracting 1 10,000 each time, that's just like counting back in ones, but then leaving our thousands, hundreds, tens, and ones the same. So we can show place value counters to represent our counting. For this first question, we started with 135,400, which we've represented here using place value counters. Now we were counting back in steps of 10,000, so we can take away 1 10,000 counter each time. But when we do that and we've run out of 10,000 counters, what we need to do is take our 100,000 counter and exchange that for 10 10,000 counters, because 10 10,000s has the same value as 100,000. So now we can keep on counting back in 10,000s until we get to 45,400. So that's 4 10,000s 5,000s and 400s, because of course our thousands and hundreds and also our tens and ones have stayed the same. Then we started with 944,005, which we can see here in place value counters. We were counting back in 10,000s, so we can take away our 10,000s counters, but then we need to exchange one of our 100,000s for 10 10,000s. Then we can keep on counting back in 10,000s until we get to 854,005. We now have 800,000s and 5 10,000s, and then of course our thousands, hundreds, tens and ones have stayed the same. Now we need to subtract a multiple of 10,000, so a number that ends in 4 zeros. First, we have 186,000 minus 30,000. Now if we highlight our 10,000s digits, we can see that we have 8 10,000s and we're taking 3 away. So in our answer, we will have 5 10,000s and all of our other digits stay the same. So our answer is 156,000. Now 224,284 minus 70,000. This time, if we highlight our 10,000s digits, we can see that 7 is larger than 2. So what we need to do here is to move to the left and highlight our 100,000s digit as well. Now 22 minus 7 is 15, so we can replace these digits here with a 1 and a 5. All of our other digits stay the same, so our answer is 154,284. Now 369,009 minus 70,000. If we highlight our 10,000s digits, again 7 is larger than the 10,000s digit in our question, so we need to highlight our 100,000s digit as well. So now 36 minus 7 is 29, so we can replace these digits here with a 2 and a 9, and then leave all of our other digits in the number that we were subtracting from the same. So our answer is 299,009. So if we look back to this first question, we can use place value counters to represent the number 186,000. Now because we're subtracting 30,000s, we need to subtract 3 10,000s, and when we do that, we can see that we have 5 10,000s, and then the other place value counters have stayed the same, so that's 156,000. But then here, we started with 224,284, which we've represented here. But we needed to subtract 7 10,000s, and we only had 2. Now what we can do is take away 1, 2 of our 10,000s, then we can exchange one of our 100,000 counters for 10 10,000 counters, because 10 10,000s has the same value as 100,000. So now we've already subtracted 2 10,000s, so let's subtract 3, 4, 5, 6, 7. And now you can see that we have 100,000 counter because we needed to take one to exchange, and we have 5 10,000 counters. So that's why we could do 22 minus 7 to get 15, and then leave all of our other digits the same because our thousands, hundreds, tens and ones have stayed the same. Then we had 369,009, which we can see here. We needed to subtract 7 10,000s because that's 70,000. We can subtract 1, 2, 3, 4, 5, 6, then exchange, then subtract our 7th 10,000. And now, because we've exchanged, we only have 2 100,000 counters, and we have 9 10,000 counters. So that was why we could do 36 minus 7 to get 29 and then leave all of our other digits the same. Now we need to subtract a multiple of 100,000. So that's a number that ends in 5 zeros. First, we have 555,000 minus 500,000. Now if we highlight our 100,000s digits, 5 minus 5 is 0. So our answer is just 55,000. Now we have 490,000 minus 300,000. If we highlight our 100,000s digits, 4 minus 3 is 1, and then all of our other digits stay the same, so we have 190,000. And now 750,000 minus 500,000. Again, we can just highlight our 100,000s digits. 7 minus 5 is 2, and all of our other digits stay the same, so we have 250,000. And we can show the subtractions using place value counters. So for this first question, we started with 555,000, which we've shown here, and we were subtracting 500,000. Now that's the same as taking away 500,000 counters, so we're left with just 55,000. That's 5 10,000s and 5,000s. Then we had 490,000, which we've shown here, and to subtract 300,000s, we can take away 3 of our 100,000s counters to give us 190,000. That's 100,000, and we still have our 9 10,000s. Then we had 750,000, and we were subtracting 500,000. If we take away 5 of our 100,000 counters, we now have 200,000 counters, and we still have our 5 10,000 counters. So that's why our answer is 250,000. Now we have some missing number problems for adding multiples of 100, 1,000, 10,000 or 100,000. So first, 56,500 plus what equals 61,500? Well, if we highlight the digits that have changed, this 56 has changed into 61, and 56 plus 5 is 61. So our missing number must be 5,000, because 56 plus 5 is 61, but then our hundreds, tens and ones digits have stayed the same, so we need 3 zeros after the 5 to show that 5,000 has been added. Now 93,300 plus something equals 103,300. If we highlight the digits that have changed, the 9 has turned into a 10. Notice we've gone from a 5-digit number to a 6-digit number. So, because 9 plus 1 is 10, our missing number is 10,000. That's a 1 with 4 zeros on the end, because the last 4 digits of our number have stayed the same. 290,005 plus what is 590,005? Well, here it's just the 100,000s digit that has changed. 2 plus 3 is 5, so our missing number is 300,000. That's a 3 with 5 zeros on the end, because the last 5 digits in our number have stayed the same in our answer. And now 299,850 plus what equals 300,350? Well, here it's the first 4 digits of the number that have changed. Now we have 2,998 circled here, and then 3,003 circled in our answer. Now if we add 5 to 2,998, we get 3,003. So our missing number is 500, because the last 2 digits of our number have stayed the same in our answer, and 2,998 plus 5 is 3,003. So we can use place value counters to represent the addition. Our first question, we started with 56,500, which we've shown here using place value counters. Now we needed to make 61,500, and we could do that by adding 5 thousands, because remember, when we have 10 thousands, we can exchange those for another 10,000. So we can add 1, 2, 3, 4 thousands, then exchange, and then add our 5th thousand. So we've added 5,000 counters, and that's given us 61,500. Then we started with 93,300, which we've shown here. We needed to make 103,300, but we could do that just by adding one 10,000 place value counter, because now we have 10 10,000s, and we can exchange those for 100,000. So that gives us 103,300. Then we had 290,005. We spotted that only the 100,000s digit had changed, so we just needed to add 3 100,000 counters, and that gave us our answer. Then we had 299,850, which we've shown here using place value counters. Now we only needed to add 500 counters, because the tens and ones digits had stayed the same. But remember, when we add hundreds, digits to the left can still change because we need to regroup. So in our number, we start with 8 hundreds. We can add just 2 hundreds, and that gives us 10 hundreds. But we can exchange 10 hundreds for 1,000. Now we have 10 thousands, so we can exchange those for 1 10,000. And now we have 10 10,000s, so we can exchange those for another 100,000. So that was just adding 2 more hundreds, and we need to add 5, so let's add 3, 4, 5, and then you can see that we have 300,000s, no 10,000s or thousands, 300s, and we still have our 5 tens. So here, because we needed lots of exchanging, just adding 500 counters changed our number to 300,350. Now we have some missing number problems for subtracting multiples of 100, 1,000, 10,000 or 100,000. So first, 30,450 minus what equals 29,650. Well, what we can do here is highlight the digits that have changed. We have 304 circled here, and then 296 circled in our answer. Now 304 minus 8 is 296, so our missing number is 800. That's 8 with 2 zeros on the end, because we can see that the last 2 digits of our number, so our tens and ones, have stayed the same. Now 310,300 minus what equals 210,300. Well, here we can see that only the 100,000s digit has changed. 3 minus 1 is 2, so our missing number is 100,000. That's 1 followed by 5 zeros, because we can see that the last 5 digits of our number are the same in our question and our answer. 246,700 minus what is 196,700. We can see that both our 100,000s and 10,000s digits have changed. Now 24 minus 5 is 19, so our missing number is 50,000. That's because the last 4 digits of our number are the same in our question and our answer, so we need 4 zeros, zeros in our thousands, hundreds, tens and ones, to show that it's 5 10,000s that have been subtracted. 677,050 minus what is 669,050? Well, here we can see that both our 10,000s and thousands digits have changed. 77 has changed to 69 in the digits that we've circled. Now 77 minus 8 is 69, but we can see that our hundreds, tens and ones have stayed the same in our answer. So that means 8,000 has been subtracted. 77 minus 8 is 69, and our other digits have stayed the same. So because our hundreds, tens and ones are the same, we need 3 zeros after the 8 to show that it's 8,000s that we've subtracted. So now let's look back to our first question. We can show place value counters to represent the subtraction. We started with 30,450, which we can see represented here. Now we needed to just subtract 800. So we can subtract 1, 2, 3, 4 of our hundreds. But now to get more hundreds, we need to exchange. We can take one of our 10,000 counters and exchange it for 10,000s, and then we can take one of our thousands and exchange that for 10 hundreds. So now, because we've already taken away 400 counters, we can take away 5, 6, 7, 8, and we can see that that leaves us with 29,650. So here, the 10,000s, thousands and hundreds digits all changed, and that's because we needed to exchange to subtract 800s. Then we had 310,300, and we saw that in our answer only the 100,000s digit had changed, so we'd just taken away 100,000 to give us our answer. Then we had 246,700, which we can see represented here with place value counters. We saw that subtracting 50,000, so subtracting 5 10,000s would give us our answer. We can subtract 1, 2, 3, 4, then exchange one of our 100,000 counters for 10 10,000s, and then subtract our fifth 10,000. So we can see that now we have 100,000 because we needed to use one of these counters to exchange, and we have 9 10,000s. Now 677,050 is shown here using place value counters, and we saw that subtracting 8,000 would give us our answer. So we can subtract 1, 2, 3, 4, 5, 6, 7, but then to subtract an 8,000 counter, we need to exchange one of our 10,000s for 10,000 counters. So now we can subtract our 8,000, and that means that we now have only 6 10,000s because we needed to use one of them to exchange, and now we have 9,000 counters. Now we need to subtract using column subtraction. First we have 13,442 minus 5,144. So we've written the question out with our digits lined up on the right hand side. So that means our ones, tens, hundreds, thousands and 10,000s place value columns will be lined up as well. Now with column subtraction, we work from right to left. So first we have 2 minus 4. But 4 is larger than 2. So what we need to do here is go to the left, 1 less, 1 in front, and then we have 12 minus 4, which we can do because 12 minus 4 is 8. So now onto our tens column, because we exchanged, we have 3 minus 4, but 4 is larger than 3. So again, we need to go to the left, 1 less, 1 in front, and that gives us 13 minus 4, which is 9. Now 3 minus 1 is 2. We can't do 3 minus 5 using the column method, so go to the left, 1 less, 1 in front, and 13 minus 5 is 8. So then we have 0 minus nothing, so we don't need to write anything in our 10,000s column, our answer is 8,298. Now 124,485 minus 29,669. We start on the right, but 9 is larger than 5, so we go to the left, 1 less, 1 in front. 15 minus 9 is 6, 7 minus 6 is 1. We can't do 4 minus 6, so go to the left, 1 less, 1 in front. 14 minus 6 is 8. 9 is larger than 3, so here again we need to go to the left, 1 less, 1 in front. 13 minus 9 is 4, and we can't do 1 minus 2 because 2 is larger than 1, so again go to the left, 1 less, 1 in front, and 11 minus 2 is 9. Now we have 0 minus nothing, so we don't need to write anything in our hundred thousands place. Our answer is 94,816. Now we have 214,489 minus 47,969. 9 minus 9 is 0, 8 minus 6 is 2. We can't do 4 minus 9, so go to the left, 1 less, 1 in front. 14 minus 9 is 5. We can't do 3 minus 7, so go to the left, 1 less, 1 in front. 13 minus 7 is 6. We can't do 0 minus 4, so go to the left, 1 less, 1 in front. 10 minus 4 is 6, and now 1 minus nothing is still 1. So we have 166,520. So for our last question, we have 352,063 minus 147,445. 5 is larger than 3, so go to the left, 1 less, 1 in front, and now 13 minus 5 is 8, 5 minus 4 is 1, 4 is larger than 0, so we can't do 0 minus 4 using the column method, so again, go to the left, 1 less, 1 in front. 10 minus 4 is 6. We can't do 1 minus 7, so go to the left, 1 less, 1 in front. 11 minus 7 is 4. 4 minus 4 is 0, and 3 minus 1 is 2. So that gives us our answer, 204,618. Now to understand why this method works, so why we go to the left, 1 less, 1 in front, let's show place value counters to represent the subtraction. So first we started with 13,442, which we have represented here with place value counters. Now what we need to remember is that we can exchange one place value counter for 10 of the place value to the right. So because we can exchange 1 10 for 10 ones, that means that we can take 4 ones away. We can subtract 1, 2, then exchange, then subtract our third and fourth one. And you can see that when we do that, we now only have 3 10s, so that's why we had 1 less 10. But we now have 8 ones, so that's why we have an 8 as the ones digit of our answer. Then we had 3 10s but needed to take 4 away. So again, we needed to exchange one of our hundreds for 10 more 10s. So we can subtract 1, 2, 3, then exchange, then subtract our fourth 10. So that leaves us with 9 10s, so 9 as the tens digit of our answer. But now, because we exchanged, we only have 3 hundreds. We took 100 away to give us 2 hundreds in our answer, but then we needed to subtract 5 thousands. We can take away 1, 2, 3, and then exchange with our 10,000 counter. We can exchange our 10,000 counter for 10 more counters. So then, because we've already taken away 3,000 counters, we need to take away 2 more, so that we've subtracted 5,000s altogether. And you can see that we now have 8,000 counters, so that's why we have an 8 as the thousands digit of our answer. Then we started with 124,485, which we've represented here. First, we needed to subtract 9 ones, but to do that, we had to exchange one of our tens for 10 more ones. So to subtract 9 ones, we can subtract 1, 2, 3, 4, 5. Then we can exchange one of our tens for 10 more ones. Then we can subtract the rest to get 6 ones in our answer. So now, because we've exchanged, we only have 7 tens, and we can take 6 tens away. That's 1, 2, 3, 4, 5, 6, to get 1 as the tens digit of our answer. Now we need to subtract 6 hundreds. We can subtract 4 hundreds, then exchange, then subtract 2 more. So we can take away 1, 2, 3, 4 of our hundreds, exchange one of our thousands for 10 more hundreds, and then subtract 2 more. So that's why we have an 8 as the hundreds digit of our answer. Now we need to take away 9 thousands. We can take away 1, 2, 3, then exchange, then take away 4, 5, 6, 7, 8, 9. So now we have 4 as the thousands digit of our answer, and because we exchanged one of our 10,000s, we now have only one 10,000 counter, but we need to take 2 10,000s away. So we can take 1 away, and then we can exchange our 100,000 for 10 10,000 counters and take away 1 more. So that means that we have 9 as the 10,000s digit of our answer, and because we exchanged, we don't have any 100,000s. Then we had 214,489. First, we subtracted all 9 of our ones to leave us with 0 ones in our answer. Then we subtracted 6 of our tens to leave us with 2 tens in our answer. But then we needed to take away 9 hundreds. We only have 4 hundreds, so again we're going to need to exchange. We can take away 1, 2, 3, 4, exchange, and then take away 5, 6, 7, 8, 9. So that leaves us with 5 hundreds. Then we needed to take away 7 thousands. So again, because we only have 3, we're going to need to exchange our 10,000 counter for 10 more thousands. So we can take away 1, 2, 3, exchange, then take away 4, 5, 6, 7 to leave us with 6 as the thousands digit of our answer. So now we don't have any 10,000 counters, but we need to take 4 away. So what we need to do is take one of our 100,000s and exchange that for 10 10,000s. So now we can take 4 away, and that leaves us with 6 10,000s, but because we exchanged, we only have 1 100,000 counter. Now we have 352,063, which we've shown with place value counters here. First, we needed to subtract 5 ones. We can take away 1, 2, 3, then exchange, then take away 4, 5 to give us 8 ones in our answer. Now we have 5 tens because we needed to exchange, and we took away 4 tens to give us 1 10 in our answer. But now we don't have any hundreds, but we need to take 4 hundreds away. So first we need to exchange one of our 1,000 counters for 10 100 counters. Then we can take 4 away to give us 6 hundreds in our answer. Now we need to subtract 7 thousands. We can subtract 1,000, exchange, then subtract 2, 3, 4, 5, 6, 7 thousands to give us 4 thousands in our answer. We need to subtract all 4 of the 10,000 counters that we have left, so in our answer we have 0 as the 10,000s digit, and then we just need to take away 1 of our 100,000s counters to give us 2 as the 100,000s digit of our answer. Now, we need to subtract using column subtraction, but for these questions, we'll need to exchange across 0. That means when we need to exchange and we go to the left, we'll have a 0, so we'll need to go to the left again and exchange more than once. So first, we have 10,005 minus 5,245. So we've set the question out with our digits lined up on the right-hand side. 5 minus 5 is 0, but now we have a 0 minus 4. Now 4 is larger than 0, so we need to exchange, but when we go to the left, we have a 0. So we need to go to the left again, but we still have 0. So we need to go all the way over to this 1 in our 10,000s, and 1 less, 1 in front. Then we need to exchange again. 1 less than 10 is 9, so now we have a 1 to put in front of our hundreds digit. But we need to exchange one more time, so 1 less than 10 is 9, and then we have a 1 to put in front of our tens digit. So now we have 10 minus 4, which is 6, 9 minus 2 is 7, 9 minus 5 is 4, and now 0 minus nothing is 0. So our answer is just 4,760. Now 166,005 minus 85,936. We can't do 5 minus 6 using column subtraction because 6 is larger than 5. When we go to the left, we have a 0, and then we go to the left again, and we have another 0. So we need to go to the left once more, all the way over to our thousands digit. Now 1 less than 6 is 5, and that gives us 1 to put in front of our hundreds. But now 1 less than 10 is 9, and we have 1 in front of our tens, and then we need to exchange once more. So 1 less than 10 is 9, and now we have a 1 to put in front of our ones digit. So we have 15 minus 6. That's 9, and now 9 minus 3 is 6, 9 minus 9 is 0, 5 minus 5 is 0. We can't do 6 minus 8, so go to the left, 1 less, 1 in front. 16 minus 8 is 8, and now we have 0 minus nothing, so that's 0, which means our answer is 80,069. Now 404,004 minus 35,488. 8 is larger than 4, so we go to the left, we have a 0, go to the left again, we have another 0, so we go to the left for a third time. 1 less, 1 in front, then again 1 less, 1 in front, and again 1 less, 1 in front. So now 14 minus 8 is 6, 9 minus 8 is 1, 9 minus 4 is 5. We can't do 3 minus 5 using column subtraction, and we go to the left and we have a 0. So we go to the left again, 1 less, 1 in front, and again 1 less than 10 is 9, and that gives us 1 to put in front of our thousands digit. So we have 13 minus 5, which is 8, 9 minus 3 is 6, and 3 minus nothing is 3. So our answer is 368,516. Now for our last question, we have 392,003 minus 139,549. 9 is larger than 3, so we go to the left, we have a 0, go to the left again, we have a 0, so we go to the left again. 1 less, 1 in front, 1 less, 1 in front, and again 1 less, 1 in front. 13 minus 9 is 4, 9 minus 4 is 5, 9 minus 5 is 4. We can't do 1 minus 9, so go to the left, 1 less, 1 in front. 11 minus 9 is 2, 8 minus 3 is 5, and 3 minus 1 is 2. That gives us 252,454. Now to understand why this method works, let's show place value counters. So for the first question, we had 10,005. That's 1 10,000 and 5 ones. First, we subtracted 5 ones to get 0 ones in our answer. But then we didn't have any tens, and we needed to take 4 tens away. So we needed to exchange, and then exchange again, and then exchange for a third time. So we can exchange our 10,000 place value counter for 10 thousands. Then we can take one of those thousands and exchange it for 10 hundreds. And then we can take one of our hundreds and exchange that for 10 tens. So now notice we don't have any 10,000s because we exchanged our 10,000s counter for 10 thousands counters. Then we took one of those thousands counters and exchanged it for 10 hundreds. So that means we have 9,000s. But then we took one of our hundreds counters and exchanged that for 10 tens. So now we can take 4 tens away to get 6 tens in our answer. We can subtract 2 hundreds to give us 7 hundreds, and we can subtract 1, 2, 3, 4, 5 thousands to give us 4 thousands in our answer. Then we had 166,005, which we've shown here using place value counters. First, we needed to subtract 6 ones. We can subtract 5 ones, but then to subtract a 6th one, first we need to exchange one of our 1,000 counters for 10 hundreds. Then we can take one of our hundreds and exchange that for 10 tens, and then we can take one of our tens and exchange that for 10 ones. Remember, we've already subtracted 5 ones, so to subtract 6 ones, we need to just subtract one more one, and that means that we have 9 ones in our answer. But notice, because we exchanged, we now have only 5 thousands, 9 hundreds, and 9 tens. So then we subtracted 3 tens to give us 6 tens in our answer. We subtracted all 9 of our hundreds, and that meant the hundreds digit of our answer was a 0. Then we subtracted 5 from our 5 thousands, and that meant we had 0 as the thousands digit of our answer as well. Now we needed to subtract 8 10,000s. We can subtract 1, 2, 3, 4, 5, 6, then take our hundreds thousands counter and exchange. Then we can subtract 7, 8. So that leaves us with 8 as the 10,000s digit of our answer, and because we exchanged, we don't have any 100,000s. So our answer is 80,069. Then we had 404,004, which we've shown here using place value counters. First, we needed to subtract 8 ones. To do that, we needed to exchange one of our thousands for 10 hundreds, then exchange one of our hundreds for 10 tens, and then exchange one of our tens for 10 ones. So we can subtract 1, 2, 3, 4 of our ones, then we can exchange, then exchange again, and then exchange again. So we've subtracted 4 ones, we need to subtract another 4, so we've subtracted 8 ones altogether, and that means that we have 6 ones in our answer. Now, because we exchanged, we have 9 tens, and we need to subtract 8 of those tens to leave us with just 1 10 in our answer. And we have 9 hundreds now, because we exchanged. We can subtract 4 of those hundreds to give us 5 hundreds in our answer. But now, because we've exchanged, we have 3 thousands, but we need to take 5 thousands away. To do that, we needed to first exchange one of our 100,000s for 10 10,000s, and then exchange one of our 10,000s for 10 more thousands. So we can subtract 3 thousands, then exchange one of our 100,000 counters for 10 10,000s, and then take one of our 10,000s and exchange that for 10 thousands. So now we've subtracted 3 of our thousands, so to subtract 5, we just need to subtract 2 more, and that means we have 8 as the thousands digit of our answer. So now, because we exchanged, we have 9 10,000s, and we need to take 3 away. That means that we have a 6 as the 10,000s digit of our answer, and we weren't subtracting any 100,000s, so we still have 3 100,000s. Then we had 392,003, which we've shown here with place value counters. But first, we needed to subtract 9 ones, but we only had 3 ones. So to do that, we first needed to exchange one of our thousands for 10 hundreds, then exchange one of our hundreds for 10 tens, then exchange one of our tens for 10 more ones. So we can subtract 1, 2, 3 ones, then exchange again, and then exchange for a third time. So because we've already subtracted 3 ones and we want to subtract 9, let's subtract 1, 2, 3, 4, 5, 6 more ones, and we can see that we now have 4 ones, so 4 is the ones digit of our answer. Now, because we've exchanged, we have 9 tens, and we need to take 4 tens away. When we do that, we have 5 as the tens digit of our answer. Onto our hundreds, we have 9 hundreds and need to take 5 away. When we do that, we're left with 4 hundreds. But now, because we exchanged, we only have 1,000, but we need to take 9,000s away. To do that, we needed to exchange one of our 10,000s for 10 more thousands. So we can subtract 1,000, then exchange, then subtract 2, 3, 4, 5, 6, 7, 8, 9, and that leaves us with 2 as the thousands digit of our answer. Now we need to take away 3 10,000s to give us 5 as our 10,000s digit, and we need to take away 1 100,000 to give us 2 as the 100,000s digit of our answer, 252,454. Now we have some missing number addition and subtraction problems. But this first question isn't really a missing number problem at all, and that's because all we have on this side of the equal sign is an answer box, and it doesn't matter whether the equal sign comes at the start or at the end of a calculation, we do the same thing. We just need to add 656,571 and 203,947. 1 plus 3 is 4, 7 plus 4 is 11, so 1, 1. 1 plus 5 plus 9 is 15, so 1, 5. 1 plus 6 plus 3 is 10, so 1, 0. 1 plus 5 plus 0 is 6, and 6 plus 2 is 8. So our answer is 860,514. Now, something plus 58,392 equals 292,020. So here we have a missing number addition problem, and whenever we have a missing number in an addition calculation, we always use subtraction to find our missing number. So here we need to work out 292,020 minus 58,392. We've lined the digits up on the right hand side. 2 is larger than 0, so we need to go to the left, 1 less, 1 in front, and 10 minus 2 is 8. Now we have 1 minus 9, so we need to exchange. But when we go to the left, we have a 0, so we need to go to the left again, 1 less, 1 in front, and then 1 less than 10 is 9, and that means we can put 1 in front of our tens digit. So we have 11 minus 9, which is 2. 9 minus 3 is 6. We can't do 1 minus 8 using the column method, so we go to the left, 1 less, 1 in front. 11 minus 8 is 3, 8 minus 5 is 3, and 2 minus nothing is 2. So our missing number is 233,628. Now 654,674 minus something equals 536,536. So in this question, it's the second number of our subtraction that's missing. And when the second number is missing, we still use subtraction to find our missing number. We need to work out 654,674 minus 536,536, and that will give us our missing number. Now 6 is larger than 4, so we go to the left, 1 less 1 in front. 14 minus 6 is 8. 6 minus 3 is 3. 6 minus 5 is 1. We can't do 4 minus 6, so go to the left, 1 less, 1 in front. 14 minus 6 is 8. 4 minus 3 is 1, and 6 minus 5 is 1. So our missing number is 118,138. Now something minus 147,445 equals 82,910. So here we have a missing number subtraction, but this time it's the first number of our subtraction that's missing. Now remember, subtraction problems can be read backwards as addition problems. So because it's the first number of our subtraction that's missing, we need to add to find our missing number. 5 plus 0 is 5, 4 plus 1 is 5, 4 plus 9 is 13, so 1 3, 1 plus 7 plus 2 is 10, so 1 0, 1 plus 4 plus 8 is 13, so 1 3, and 1 plus 1 is 2. So our missing number must be 230,355. Now we have some missing digit problems for column subtraction, and the way to solve these is to work through the problem in the same steps that we use for column subtraction. So that's working from right to left, so starting with our ones place value column. We have 8 minus something, and we have a 0 in the ones digit of our answer. So we know that this digit here must have been an 8, because 8 minus 8 is 0. Now onto our tens, we have something minus 1, and we have a 4 in our answer. 5 minus 1 is 4, so this digit here must be a 5. But now onto our hundreds, it gets a little bit trickier. We have 0 as the hundreds digit, and then something has been subtracted to leave a 1 in our answer. Now we know that they haven't subtracted from 0 to get 1. They must have exchanged, and because they exchanged, we need to exchange as well. So that's 1 less, 1 in front. So now we have 10 minus something, and we have a 1 in our answer. So this digit here must have been a 9, because 10 minus 9 is 1. Now onto our thousands, we have 3 minus 8. So we need to go to the left, 1 less, 1 in front, and then 13 minus 8 is 5. Now we have 0 minus something, and we have a 3 in our answer. So we haven't subtracted from 0. They must have exchanged and then subtracted from 10 to get 3. 10 minus 7 is 3, so that's our last missing digit. Now onto this question, again we start with our ones. We have something minus 7, and we have a 6 in our answer. Now we know that if we add 6 and 7, we get 13. So they must have subtracted 7 from 13 to get 6. That means they must have exchanged, so 1 less, 1 in front, and then this digit here must have been a 3, because 13 minus 7 is 6. But when we're writing the missing digits, it's best to only write the digit in the answer box, so we can rub this one out here because the digit was a 3. Now we have 7 minus something and 3 in our answer line, so 7 minus 4 is 3. But now, onto our hundreds, we have 0 minus 5. So we know that they must have exchanged, but we don't know the digit that they exchanged with. So we can just put a cross through this box for now, and we know that exchanging would have meant that we could put a 1 in front of our hundreds digit. So now 10 minus 5 is 5, and onto our thousands, we have something minus 7, and we have an 8 in our answer. Now 8 plus 7 is 15, so they must have written 15 up here, because remember they had to exchange here, and 15 minus 7 is 8. Now to get the 5 in 15, this digit here must have originally been a 6, and then when they exchanged, they changed it to a 5 so that they could put a 1 in front of their hundreds digit. And to get the 1 in 15, they must have exchanged with this 8 in the 10,000s, so that would have become a 7. So now 7 minus 4 is 3, and then we just have something minus 1 and 7 as our answer, so this digit here must have been an 8. Now for these questions, we're subtracting a larger number from a smaller number. And you might think that we can't do that, because we can't do that using column subtraction. But we can subtract a larger number from a smaller number. All it means is that our answer will be negative. So, on a number line, below 0, we can count back minus 1, minus 2, and so on, and that can help us subtract. So first, we have 3 minus 7. So on our number line, we can start at 3, and then to subtract 7, we can count back 1, 2, 3, 4, 5, 6, 7. So because we've got to minus 4, that's our answer. Now we could have also solved this by first subtracting 3 from 3, and 3 minus 3 is 0. But then, because we need to subtract 7, we need to subtract another 4. Because if we subtract 3 and then subtract 4, we've subtracted 7 altogether. And 0 minus 4 is minus 4, so that's our answer. Now we have 4 minus 9. So on our number line, we can start at 4 and then count back 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is minus 5. Or what we could have done is make one jump of 4 to get to 0, because 4 minus 4 is 0. But then, because we've only subtracted 4 and we need to subtract 9, we need to subtract another 5, and then 0 minus 5 is minus 5. Now we have 1 minus 8. So we can start at 1 and count back 1, 2, 3, 4, 5, 6, 7, 8. So we get to minus 7. Or we could have just counted back 1 to get to 0, but then, so that we've counted back 8 altogether, we could have made another jump of 7, because if we subtract 1 and then subtract 7, we've subtracted 8 altogether, and 0 minus 7 is minus 7. So here we can see that because the number that we were subtracting is larger, our answer was negative. But you might also spot that 7 minus 3 is 4, 9 minus 4 is 5, and 8 minus 1 is 7. Now when we're subtracting, order matters, so we can't switch the digits around. But once we'd realised that subtracting a larger number would give us a negative answer, we could have just written our negative sign and then subtracted 1 from 8, or subtracted 4 from 9, or 3 from 7. And the reason why we can do that is because if we look at our number line, subtracting to get to 0 always means subtracting the number that we start with, and then once we've done that, subtracting that number from the number that we need to subtract tells us how many more we need to subtract, and how many more we need to subtract is always our answer. So here, because we'd subtracted 3, we needed to subtract another 4, so got minus 4. Here, because we'd subtracted 4, we needed to subtract another 5, so got minus 5. And here, because we'd subtracted 1, we needed to subtract another 7, so that's why our answer was minus 7. Now, we need to subtract to make a negative answer. And for these questions, we can see that our answer will be a negative number, because 72 is larger than 26, 85 is larger than 5, and 91 is larger than 89. So first, we have 26 minus 72. We can represent the subtraction on a number line. So from 26, if we subtract 26, that will take us to 0. And then from 0, because we want to subtract 72 altogether, we need to subtract another 46, because 26 and 46 together make 72. So 0 minus 46 is minus 46. Now it might not have been clear that we needed to subtract 46. So what we can do is work out 72 minus 26, because that tells us how many more we need to subtract from 0. We can't do 2 minus 6, so we exchange. 12 minus 6 is 6, 6 minus 2 is 4. So that told us that from 0, because we'd already subtracted 26, we needed to subtract another 46, so that we'd subtracted 72 altogether. So our answer is minus 46. We know that because the number we're subtracting is larger, we're going to need a minus sign. But then, to get the number after the minus sign, we can do 72 minus 26, because that tells us how many more we need to subtract from 0. Now we have 5 minus 85. Starting at 5, we can subtract 5 to get to 0, but then we need to subtract another 80, so that we've subtracted 85 altogether, and 0 minus 80 is minus 80. Again, we could have done 85 minus 5, and because that tells us that we need to subtract 80 from 0, that tells us that our answer is minus 80. And now we have 89 minus 91. Starting at 89, we can subtract 89 to get to 0, but then we need to subtract another 2, so that we've subtracted 91 altogether, and 0 minus 2 is minus 2. If we do 91 minus 89, we get 2, and that tells us that from 0 we need to subtract 2, which is why our answer is minus 2.